And how could the location be okay if it's not a real account? And the whole concept of a location being acceptable has to do with the property of the cardholder and where one would expect the cardholder to be making charges. So we have some nonsense here. And of course that makes sense. I mean, we generated all the combinations, so it wasn't any guarantee that some of those combinations weren't going to be nonsensical. So maybe you say, well, in the case of these nonsensical combinations, I can't actually create those from a test point of view. And so I can look at them and say, all right, well, I can't make this happen, and therefore, one would presume that the charges would not be approved. Now, of course, the right actions would not be taken in the sense that there wouldn't be any actions taken because it couldn't happen. So maybe these full decision tables, while a useful starting point to assure ourselves that all of the combinations of conditions have been covered, are actually not useful from a test point of view because they contain a lot of unachievable tests. So this brings us to the concept of collapsing a decision table. Now, what I'm going to do is I'm going to try to look for combinations of particular conditions where one of the conditions, or maybe two of the conditions, or more of the conditions, actually cannot affect the actions that will occur under a particular set of circumstances. And so I can, in that case, say that a particular condition in the overall set of conditions has a don't care or doesn't matter or can't happen value, and replace that particular condition with a dash or a tilde to indicate that, and then collapse the two columns together. So this is a tricky procedure potentially because it's certainly not impossible to make mistakes here. So one must be careful when you're doing it. Now, the decision tables often have the property where combinable columns will be right next to each other in the table. So you start off by looking at columns that are right next to each other and say, well, is one of the conditions here not actually affect the action to be taken? And if so, can I then squeeze these two together, these two columns together, replacing the condition or conditions that don't matter with a dash, and keeping the conditions that do matter unique. And methodically, you can walk through the table and try to collapse the columns, and you continue this process until there's either no columns that share any sort of combination of actions in common. So if you look at the particular combination of actions to be taken, they're all unique. Then clearly, in that case, there could be no collapse. But what you're more likely to run into first with this attempt to collapse is the erasure of an important distinction. And so you have to, when you go to collapse, you have to test whether that the collapsed column that you are proposing would indeed handle the same situations the same way as the non-collapsed ones. And this is very important because if that is not the case, then you are erasing an important distinction in the table, and of course your collapsed table is not actually logically equivalent to the full table, which that thus makes it wrong. So that's important. We'll look at an example of that. Now, you have to be particularly careful with tables that have what I refer to as non-exclusive rules, and I'll show you an example of this a little later. But briefly, a non-exclusive rule is the case where two or more columns in the decision table can apply to a given situation. And I'll show you how that works. We'll set that aside for the moment. And let's look at the collapsed decision table for the full decision table we looked at previously. Now, I've retained the original column numbers at the top so that you can reference back more conveniently to the full table. So this gives us some trickiness here potentially. Notice that Rule 3, Rule 4 collapsed into it, because the difference between Rule 3 and Rule 4 was just whether the location was okay or not. But in either case, the transaction would not be approved. The cardholder would not be called, or would be called, excuse me, and the vendor would not be called. So let's pop back to look at this in the full table here. So if we look at in the full table, Rules 3 and 4, see, that's the only difference there. The question of whether the location's okay or not, right? And the actions to be taken are identical. Oops. Let's draw inside the lines here if I should. So we can collapse those two. Now, let's go forward. Okay, so we got 3 to 4 collapsed into each other, but now we got to look at, how about 2 and 3? Couldn't we collapse 2 and 3 together? Because after all, they share the same set of actions. And couldn't we just put a don't care here and replace that with a don't care? And wouldn't that be okay? Well, no. It actually wouldn't, because if we said we don't care whether we're within limit or not, and we don't care whether we are in proper location or not, neither of those matter, well, that's not true, because that would erase the distinction between rule number 2 and rule number 1, right? And obviously rule number 2 and rule number 1 are quite different. They're almost opposite in their outcomes, certainly in terms of, they are opposite in terms of approval. And, one results in a decline in the call to cardholder, and the other results in approval and no calls to the cardholder. So you have to be very careful about collateral damage, if you will. That collapsing 2 and 3 would seem to be okay at first, but it would also create a situation where the resulting rule, which would be yes, yes, dash, dash, would also collide with rule number 1, and that would destroy the operability of the decision table. So that would not be a happy circumstance, so we don't want that to happen. Same thing for rule number 8 and collapsing into rule 7. That was fine, but if you try to collapse rule 7 into 6, then you would erase the distinction between that and 5, and then you'd be in the same bowl of soup. So it's important, as I said, to test these out, because if you don't, then you will destroy the logic of the decision table. Now, let me mention, obviously, the collapsed decision table, you lose the properties of the full decision table in terms of the formula for the number of columns, 2 to the number of conditions power. That's not going to apply anymore. And the regular pattern of the conditions, of course, also goes away. And you can see up here at the top half of the table, let's get this off of here. We used to have that nice pattern of yeses and nos up here that you could look at and inspect, and now, of course, we don't. That's part and parcel of the benefit of collapsing this thing. Notice that we're a much smaller table now. We've got 2, 4, 6, 7 columns instead of 16. So anything that cuts your testing workload in half is a good deal, in my opinion. You might be one of those lucky people that has nothing but free time, but most of us, free time is something we don't really have. Okay, so cause-effect graph. Now, let me start with a caveat, I guess I'd say, or point of personal privilege. I don't really care much for these things, these cause-effect graphs. Now, if my friend and colleague Gary Moseriotti is on the line listening to this, I'm sure he's just like bursting out of his skin right now, because he loves these things and he thinks they're great, and can make them do all sorts of magic from a test point of view for him.